So what we were doing was finance, right? Two types. We either can have a simple interest or we can have a compound interest. What's the formula for simple interest, if you remember? What's the formula for A, the amount? It's P.
T and then a bracket 1 plus R times T.
All right. What about for compound interest? There's still the P element. There's a bracket as well. What goes in the bracket?
1 plus I to the power of N.
Yeah, 1 plus I to the power of N. So again, in both of these, A is the final amount. P is the principal amount, which is the initial amount, right? R is the rate, so is the I. T is the time, so is the N. It's just a notation to distinguish which one is which. And simple interest is pretty straightforward. There's nothing fancy going on. And in both of these guys, the interest is just the final amount minus the principal for both of them. For compound interest, sometimes they will give you the final amount, right? They'll give you the final amount and they would want you to find the principal. In that case, you would divide both sides by this bracket like this. That's one case. There's three cases. If I is missing, then you want to do the 10th root or whatever root. Okay, if I is missing, then you'll get to it because N will be given. So for example, you'll get to this level, maybe 10 years, then you want to take the 10th root on both sides. So if I is missing, you take the nth root, whatever that number could be. If N is missing, that's the time, right? If N is missing, because it's in the exponent, what do we do here?
You do log.
Yeah, exactly. If N is missing, we do log, and this is pretty much it. But sometimes it won't be compounded annually, right? It won't be compounded annually. So we have quarterly. Let's just give two examples. Semi-annually. What do we do if the interest rate is compounded quarterly?
You divide it by 2.
Quarterly is 4. You
Oh,
divide
4.
the
Okay.
4 quarters, right? 1/4. Quarter is a 1/4, and then time is 4. Semi-annually, what about in this
This
case?
one's 2.
This one is 2, right? Then you can have monthly. Again, this one is just count the days, right? It's going to be 12 divided by 12 times 12. You can also have daily, which is what banks do these days, which is going to be 365. Okay.
Okay.
To maximize the interest, the more often it's compounded, the higher the interest. So that's why you have to be careful with credit cards, because the interest rate that you're going to have to pay back, if you can't pay back, it's going to be very high, which is also going to be reflected on your credit score. Let's do a quick question here and we will get out of this. All right, here what's given. APR, not R, should be IN.
A is 12,000 and P is 5,000.
Right. What's I?
I would be 0.054 divided by 2.
That's right. What about N?
N would be the unknown, but you would multiply it by 2.
Yeah, that's right. So N is 2N here because it's semi-annually. So let's set this up. A is equals to P, 1 plus I to the power of N, right? And then this is going to give us 12,000 is equals to 5,000. 1 plus 0.027. So you get this to the power of 2N. Now what?
You divide by 5,000.
Right, you divide by 5,000. I think it's going to be 2.4, 5,000. Yeah. On the other side, we have 1.027 to the power of 2N. Now what?
You would use log.
Right, because the unknown is in the exponent, we're going to have to use logs. So it becomes log of 2.4 is equals to log of 1.027 to the power of 2N. Why do we use logs? Because now we can bring the exponent on the same level, right? Like this. What's next? We're trying to solve for n, which is our unknown.
Now you would divide by log and then by 2.
That's right. So log of 2.4 divided by log of 1.027 divided by 2. And that gives us n is 16.4 years. So it's going to take 16.4 years for her money to double, more than double, which isn't a bad time, to be honest. 16.4 is pretty good. Cool.
Mm-hmm.
This is for cash, right? These rates are for cash. There are some other investments that you can do, like stocks and stuff, whose rates are gonna be considerably higher. But with stocks, like it's not a guaranteed. Like these would be guaranteed because it's in your savings account, and there's no way around it. But stocks is gonna be could be like this, but then one day it can just jump down, like like this, like this. So let's look maybe an example. What would be a good example in this case of stocks going down? Like Twitter was pretty high. Actually, it wasn't that high. So Twitter had something like this kind of, it was like this. And then one day it just kind of went up. This is when the richest guy on earth decided he would buy Twitter. Okay. So the stocks went up. Yeah. And then he later said he doesn't want to buy it. And then the stocks went down. So what's going on there? So that could be an example of that. Another good example is cryptocurrency, Bitcoin. Bitcoin did something like this, whoop, but then it also does whoop. So this is very volatile. So these guys are high risk, high reward. Savings account would be low risk, low reward. At least your money is safe, okay? The next topic here is gonna be something called annuities. Now, what is annuities? We haven't seen this yet, but instead of having one amount, right? Instead of having one amount and letting it grow and getting a final amount, what annuities is that you give small amounts in chunks, okay? Let's say you deposit $50 every month into an account, okay? You'll earn interest on this, and what's gonna be the final amount? But then you can't just do 50 times 4. That's your p-value. You can't do this because this is going to earn its own interest, and then you're going to earn interest over interest. It's a little bit complicated, this one. So what's an example of annuities? Mortgage is probably the best example because you buy a house, maybe that's, I don't know, $500,000, right? You give like, I don't know, 100K in down payment. And most banks require you to pay a certain amount, usually 20% in down payment. And the remaining 400,000 you'll pay over, usually it's 25 years, okay? Usually it's 25 years, and the interest rate is gonna be, that depends. So this one's gonna depend on the date and the time. Right now it's pretty high. In the COVID, when it first hit, it was pretty low. And then you pay this. So what does this mean ultimately? You'll end up actually paying them back after 25 years. You'll probably pay them back 500K. But it doesn't work like you don't pay one big chunk back. For 25 years, every month, you're gonna pay like $2,500 or something every month. Okay? This is annuities. And this rate that you pay, the money that you do pay every month, this is going to be your, the notation is R. This is gonna be your monthly payment. Well, it doesn't have to be monthly. Depends on how it's compounded, right? This one's compounded monthly, but this is gonna be your periodic payment. Periodic means like, depends on how often it's compounded, okay? Another example of annuities is, you can also go the other way around, like the example that we first saw. You don't have to buy a house. What if maybe you're trying to save up for college, right? You're trying to save up for college, car, whatever. So from your like, I don't know, 16, 18, you start putting like $200 from your paycheck into a bank account, right? $200 every month. So this one, you'll get paid interest. So let's say you put in $200 every month for a year. So you actually put in $2,400, yeah? But you'll see after a year, because you're going to earn interest on the money on the first month, but then on top of that, you're going to earn interest on the small interest that you earned. So it's interest over interest, and it carries forwards.
Okay.
So you'll probably end up paying 26. You'll probably earn $2,600 or something. Cool.
Mhm.
Another example would be if you finance a car, same idea as the mortgage. Maybe it's like $50,000, but the car would be usually paid within 5 years. You pay like $300 a month for 5 years every month, stuff like that. And the periodic payment is your R value, okay? Periodic payment is your R value. So when it comes to annuities, there's two types. There's two types, and this is the trick. You're gonna have to be able to distinguish. One of them is called the present value, okay? One of them is the present value. The other one is the future value. An example of a present value annuity would be this. You buy a mortgage, right? You already have that amount with you, right? You already have that amount with you. So this would be present. When you buy a car, you already have that amount. You borrow that amount instantaneously on the day of, yeah? On the day of. What else could be? Anything, basically anything that you buy. Another one would be like cell phones, the plans that we have where we pay them monthly. Those would be present values because we already own it. Yeah, we already own it. We basically borrow the entire sum instantaneously. We're gonna pay them in periods. Future value is a little bit different, and they both have different formulas, slightly different formulas. Future value would be maybe if you're trying to save up for college. Okay, if you're trying to save up for college. So basically, if you're trying to save up for something, or maybe anything like this, right? Maybe a loan that you want to pay off in the future. Okay. So the trick is to be able to distinguish between present value and future value. Let's see, there's a formula for this one. This is FV stands for future value, okay? Future value. R is going to be your periodic payments, and I is just the interest rate, and N is N. Okay? N is the time. And again, just like compound interest, it depends on how often it's compounded, right? So monthly, yearly, daily, so you have to take that into account. Let's look at an example question. So this person puts away $500 every 3 months, right? $500 every 3 months. And this is the interest rate compounded quarterly. How much would her annuity be worth in 25 years? So this person's putting 500 every 3 months, right? Every 3 months. And then we want to know after 25 years, how much is their total, the total amount in the bank, okay? So tell me what we know. There's again 5 things.
Wait, so what does the R and FV exactly mean again?
What does R mean? R is the amount that you put in. Periodic payment. So
Okay.
you're putting it in $500 or down 500. FV means the future value. So this is the value, like how much it's going to be worth after 25 years. Okay. What about I and N in this case?
0.052 divided by 4
Right.
for I.
0.052 divided by 4, and that's 0.013. Okay.
And then 25 times 4 for N.
What is 25 times 4? You need a calculator for that?
100.
100, right? So now let's set this up. Look at the formula. So future value is R, so 500, yeah, times 1 plus I, 1 plus 0.013 to the power of N to the power of 100 minus 1 all over I, which was 0.013, like that.
Mhm.
See that? How would we plug this in a calculator?
Uh,
Any ideas? Because basically you'll also be tested, right? You're also being tested on your calculator prowess.
so I have to do a bracket and a bracket.
Yeah, well, first, why don't you do this? First, do this, just that to the power of 100 in a bracket, okay?
Mhm.
And tell me what you get. Nothing?
It just gives me 1, and then
It gives you
when I
what?
multiply it, it gives me like 1.
1 plus 0 0.013 to the power of 100.
It gives me 1.
Don't think that's right. Let me try. 1 plus 0 0.013 to the power of 100. Nope. Oh, maybe you're not putting a bracket? Try this. 1, okay, 1.013, because that plus that is just gonna be that, right?
Oh, okay.
Try that.
Oh, I got 3.638.
Okay, now subtract 1 equals. Subtract 1 from that equals.
2.638.
Divide by 0 0.013.
I got 202.975.
Finally, times by 500.
I got 101,487.909.
Let's see if that one is right. Where'd it go? This one, right? You got this number?
Mhm.
There we go. Okay. So do you understand what's happened here in this question? This person's put in 500 every 3 months. So he puts in $500 4 times a year, right? Like that.
Mhm.
And then he does this for 25 years. Here's a better question. How much interest did he earn?
You just subtract 500.
No, not just 500. He's been putting
Oh,
500
I put every 3 months.
every 3 months for 25 years.
Uh,
So multiply 500 by 4 and then multiply that by 25.
it's 50,000.
Right. So he put in 50,000. How much did he make? He made 101,000, right? So over 25 years, he made $50,000 in interest.
Mhm.
Does that make sense?
Uh-huh.
All right, let's try another one. The formula is going to be the same, okay? The formula is going to be the same. And again, you're going to have to do the calculator bits because that's the tricky part. The math is very simple. Well, I don't know if it's very simple, but it's straightforward. It's a calculator plug and play. Again, read this question. Sam wants to make money and he would like to have, you see this wording here? He would like to have sometime in the future. That's how we know the future value is 500,000. Okay. What else do we know here? What are we trying to find?
You're trying to find R?
Right, so R is missing. What is I and what is N?
I is 0.096 divided by 12, and N is 30 times 12.
So N is gonna be 30. 30 times 12, right? That's 360. What is a 9.6, 0.096 divided by 12?
Is it like 0.08 or 0.008?
So 0.096 divided by 12 is 0.008, okay?
Okay.
0.00, and this is missing, and there you go. And our setup is gonna be 500,000 is equals to R, which is missing, all over 1 plus I, so 1 plus 0.008 to the power 360 minus 1, all over I, 0.008. Now remember how we did this last time. You just want to do this part first. Just do this first, and then this bracket is done. Then we're going to subtract 1 in the next step, and then we're going to divide by 0.008 in the third step. Try that, see what you get.
I got 200,076.413.
200,000, let me see, 1.008 to the power 360, 1.008 to the power 360 minus 1 divided by 0.008. I got 2076.41. So I did this part first, and then you want to subtract 1 in the next step, and then whatever you get, you want to divide by 0.003 in the third step.
Oh, now I got the same thing.
Okay, how do we find the next answer here?
Do you divide that?
Oh yeah, you do. So divide 500,000 with what you got, 2076 point this. 500,000 divided by 2076.4.
I got 240.801.
Okay, what does that represent?
The amount he should deposit each month.
Right, so that's the amount you should put in the bank every, how much? Every month, right? Yeah, there you go. This could literally be like the mortgage question that we talked about. If the house Well, this is going to be a reverse mortgage. So you're saving it, okay? You're saving it for a future time.
Mhm.
Real life example of this would be saving up to retire. You ever heard about CPP, Canadian Pension Plan? For this is how it works as well.
Oh,
Depending on which province you're in, I don't know for Alberta, but depending on which province you're in, a portion of your paycheck, every paycheck, yeah? When you start working,
Mhm.
a portion of your paycheck goes to the Canadian pension plan. So you're basically putting in a couple of hundred every month for however much you work. Now, what's the benefit of doing this is because you can choose to retire, right? So this depends on people to people. You can choose to retire at 60, 65, 70. Depending on how late you want to retire, you'll get paid more every month. So this person would
Mhm.
get paid $240 every month extra at the end.
Okay.
Every month. Well, it's not going to be 240. It's going to be probably like for us, for Canadian, most Canadians, it's going to be like about $2,000. But then that can run out as well. It depends on how long you work for and when you started working and how much money you made. So for example, if you start working from 16 and then you worked your way up to like a nice job in your 20s and then you worked all the way to your 60s or 70s, then you get a lot every month from the CPP. But let's say you work at 25, you work retail, you get sick at 50, you want to retire, then you probably get like $800 a month. So it depends on how long you've been working and what kind of jobs you've had, okay? Same kind of idea here. Tell me what we know.
The future value is 95,000.
Right. How do we know it's the future value and not the present value, actually?
Because you're borrowing that money, you're not giving it, like you're not investing it at first.
Does she have this money right now?
No.
But she borrowed it, right? She borrowed it.
So it's not future value?
Trying to think. Future value is when you'll have saved up to something in the future. This person's borrowed it right now. I don't think this is future value. The wording doesn't make, yeah. They tricked us. This is not a future value. And you can think of it that way as well, right? This person's borrowing the money right now. Look at the difference between this question and last question. In the last question, he would like to have this at the end of 30 years, right? In this question, this person wants this money today, right?
And they get it because
And they get it. They're borrowing, yeah. And they're going to pay it off later, right?
Okay.
So this is not a future value question. Okay, this is a present value question. They use technology to do this Excel. Don't worry about this. We'll do this in the next section. The next section is going to be called present value. There's a formula for this one as well. It's a little bit different than this.
Okay.
Okay, the formula is the same. Actually, again, you have to be careful. Okay, you have to read between the lines. So that's the difficult part, like distinguishing, is it future value or is it present value? Because then we're going to have to use different things, different techniques. This person would have to would want at least 6,500 at the end of his investment.
So that's future value?
That is 100% future value. He would want this at the end or after a couple of years. So we know future value is that. What else do we know?
R is 250.
R is 250, yes.
I is 0.052 divided by 4.
That's right, which is 0.013.
And then N is unknown.
N is the missing bit, okay?
4N.
Yeah, n would be the missing bit, which is 4n. So now let's set this up, and you're gonna have to use your algebraic skills here to solve this guy. And again, you can always add them up. 1 plus I'm just gonna add them up to make our lives easier here, like this, to the power of 4n minus 1 all over I was 0.013, like that. Okay.
Mhm.
All right, now n is missing. How do we do this question? What do we do first? This is an equation. It is an exponential equation, in fact.
So do you have to use log for this one?
Maybe. Definitely, because the unknown was in the exponent, so you definitely have to use logs.
Mhm.
So what do we do first in order to solve this equation?
You divide by 200.
Yeah, that's right. Good. You divide by 200. And then what do you do? If you divide by 200, you get 32.5.
And then you have to use log.
No,
You don't?
no. You'd use a log if the 4n was on the outside like this. We can clean this up a little
Oh.
bit. All right, let's ignore the brackets. Maybe that'll give you a hint. We need to isolate this guy first. Meaning we have to get rid of the minus 1 as well as the 0.013 to the other side.
So could you add one?
Is that the right math though? Do you add one for, you gotta follow the reverse BEDMAS. Doesn't always work, but it works most of the time, okay?
Oh, so you have to multiply 0.013.
Yeah, you have to
Okay.
multiply 0.013. So 32.5 times 0.013, which is 0.4225, and then you add 1, you get 1.4225. That is equals to 1.013 to the power of 4n.
And now you use log?
Now I use logs, that's right, yeah. So you would get log of 1.4225 is equals to 4n. Again, we know if you use log, that's going to come down. Why don't you try plugging this in the calculator, one step at a time. And tell me what you get, and that's going to be in years.
I got 27.284.
Did you divide that by 4?
No.
Okay, divide that by 4.
Then I get 6.821.
That's the right answer as well, 6.821, whatever. So for this to happen, it's going to take him 6.2 years, okay? That makes sense. Annuities just
Yes.
builds up from compound interest, right? Everything kind of builds up from compound interest. You could also use Excel to do this. That's going to be a little bit tricky. Have you ever used Excel in your life?
No.
A very important skill to have. Well, actually, maybe when you're going to like 9 or 10, maybe 10, where you're required to write like reports. Like if you do science and stuff, they would ask you to write lab reports. Very powerful tool. What about Microsoft Word? Ever use that?
Yes.
Okay, so it says Excel is it's not like Microsoft Word, but it has the same kind of properties.
Like PowerPoint and stuff.
Yeah, PowerPoint is also part of the family. Like, but Excel is supremely powerful. Excel is for math. Like basically, Excel is for like math, graphs, data. When you have a bunch of numbers, right? Like if when you're doing like a physics lab report, you'll have a bunch of numbers like time and distance, yada yada. Powerful tool. Word is basically to make it look nice and pretty, turn it into a report. Word is for what it stands for. It's for words, like reports. Excel's for math. PowerPoints is for presentations.
Uh-huh.
All right, let's look at this one. What do we know?
The future value is 25,000.
Yeah.
And R is 150.
Right?
N is 10.
Compounded monthly, it says.
Oh, so you times it by 12.
All right. What about I?
That's missing.
I is going to be I over 12.
Mm-hmm.
Okay, because we gotta divide that by that. So again, this is gonna be a tricky question because, well, it's not tricky, but just have to see how we do this. To the power of 120 is n minus 1 all over I over 12. Like that, okay?
Mm-hmm.
Trying to think if this is even solvable. Should be, I think. Right. Any ideas on what the first step is going to be?
You divide by 150.
Yeah, you can divide by 150. So 25,000 divided by 150, and that's 166.67. Okay, ignore this, get rid of the bracket as well. 166.67.
Now you can add 1.
Can you add 1? You first need to get rid of the denominator before
Oh.
you're allowed to add 1, okay?
But what
So
about the I? It's not even in the denominator.
it is in the denominator. We have I over 12 in the denominator.
So do you multiply that?
Yeah.
Okay.
So you get 166.67 I over 12, and then you can add 1, okay? See, like that. It's a little bit trickier than it looks, though. Now what do you think we do?
I'm not really sure.
This is a trick question. I don't know if this is even doable because there's two things going on, yeah? If you look at this, we have an unknown up here, but we also have an unknown down there, okay? What this means is mathematically, this is going to be very difficult. You could try opening this bracket and do it like that, but that's going to be a waste of, it's going to take a very, very long time. So in annuities, when the I value is missing, things become very, very difficult, okay? So we're gonna have to use technology to do this, but you don't have to use Excel here. Let me show you another way to do this, which is called Desmos. I don't know if we've used this before. Have we?
Yes, for graphing.
Okay, so we have FV, that's 25,000, is equals to R value, the periodic payment is 150, bracket open, 1 plus I divided by 12. It doesn't use I, it uses Y and X, like this, to the power of 120, you see that? Minus 1, okay? And everything divided by X over 12 as well. There we go. And the answer is right there. Whatever that number is, what does it look like? 0.631. So I just plugged everything from here into Desmos. Okay.
Okay.
It's pretty difficult, right? So that's
Could
what
you
you do.
have done that like on your own?
Probably, but again, because there's two different, that's beyond our scope. We're gonna have to use a different type of math to do this, which we may
Okay.
eventually get to, okay? Which we may eventually get to, but that takes a very long time to do by hand. That's why like using Excel and technology it's pretty powerful. Okay.
Mhm.
So that was that. Now let's look at, what do you think we're gonna look at next? Present value. Okay, that looks like it's an Excel question. We can just ignore that. Let's look at this one. All right, what is given here?
200,000 is the present value
All right, how do you know it's the present value?
because the person borrowed it, so he has it now.
Yeah, exactly. He has it today, right? He has it today. So that means he has it in the present. That's why it's present value. What else do we know here?
N is 20. Times 12. And then I is 0.066 divided by 12.
Right, 0.066 divided by 12, which is 0.0055. What is missing? I guess the question is how much? Oh, there's two questions. How much will each monthly payment be? Yeah. What is that? It's the same thing as the other one. R is a periodic payment. Okay, it's the same thing from future values. So R is missing here. Cool. All right, so we have 200,000 here. That's a cheap house. What is this? Is it a house? It's a yacht. Okay, that makes more sense. And that is equals to R, which is missing. Okay, now look at the formula here. Okay, we have 1 minus 1 plus I to the power of negative n. See that? To the power of negative n all over I, like that. Last time we had what? 1 plus something to the power of positive. Yeah, we had it like this last time. 1 plus I to the power of n minus 1 over I. Now it's reverse. Now it's 1 minus 1 plus I to the power of a negative n. Okay. Here you go. You're going to plug this in. Tell me step by step. Step 1, plug this bit in your calculator with the bracket.
Okay.
And I'll do it with you. Let's see. Make sure to put the bracket. Make sure to include the bracket and be careful. It's negative power. Okay.
I got 0.268.
Nope. Did you do 1.0055?
I think so.
To the power of negative 240, yeah? Not positive, to the power of negative 240.
I'll try again. I keep getting the same answer, and I put it in a bracket.
1 plus 0.0055 to the power of negative 240. Okay, whatever you got, do 1 minus that.
I subtract one from that, or
Yeah, you do 1 minus 0 point whatever you got. Yeah.
now I got like negative 0.73.
Should you get a negative number? I don't think so. All right, let me try. So you have 1 plus 0.0055 to the power negative 240, right? I got R is outside here. I got 1 minus 0.268. Yeah.
Mm-hmm.
And then 1 minus 0.268, that is going to be R 0.7318 over 0.0055. That's equals to 200K on the side. You do 1 minus this, okay? 1 minus that.
Okay.
And then 0.7318 divided by 0.0055, that is 133. And then you divide both sides by 133, 200,000 divided by 133. And that gives me $1,503 approximately, point something.
Mm-hmm.
Does that make sense or no?
It
See if that's right. Yeah, 1502. I rounded it up to 1503. So let's say R is 1503. Again, remember what R means, okay? R is the amount he pays periodically. Part B is asking us for the interest.
Do you divide R by something?
No. So how much did he actually pay to the bank? He pays R. How often does he pay it? He pays it every month for how many years?
20.
20 years, right? So what does that equals to? Plug that in. I think that's going to be pretty easy to plug.
$360,220.
And now
700.
subtract the amount that he actually borrowed from the bank.
Um, 160,720.
Okay, what did you just find?
The interest.
Right, so look at that. That's outrageous how much interest you pay.
Mm-hmm.
He paid over 160,000 just in interest. It's almost the price of his yacht. How crazy is that?
Is this realistic?
It is realistic. That's absolutely, yeah, it is. Even houses, like if you have a house that's like, I don't know, like 500K or something. Well, after 30 years, you'll actually end up paying like 800K plus. You basically pay 300K just in interest, which is pretty messed up, right?
It's like a scam.
It is a scam. Well, maybe it's not a scam, but that's why there's a huge issue right now with housing in general, because people can't buy houses, right? Even if they do buy houses, even if they can't afford to pay the mortgage, they get shafted by the interest rates. It's pretty bad. That's what when I
Oh, don't they like lower the price of like the houses, but like they
yeah,
make
they
the
do.
interest rate higher?
That's right, exactly. That's what they've been doing lately. They kind of want to reel you in, right? So you can pay maybe the down payment.
That's happened to my parents right now.
Oh yeah, are they
Yeah.
mad? Oh, I feel bad. Yeah, that's exactly what happens. Okay.
Mhm.
So that was that. Let's look at another question here.
I get why math is important now.
Yeah. So you have to be see if they had done this, they would have known. Actually, no, their bank people would have told them, I think, like realistically how much they would end up paying.
Mhm.
But there's other costs, like that are associated with stuff like buying a house, like taxes, property tax, yada yada, and then like maintenance, repairs.
Uh-huh.
So it kind of just goes up and up and up. Okay. Okay, look at this question. What's given? You want to buy something, okay? You want to buy something, not tomorrow, not yesterday. You want to buy something today, and you're very stubborn about it. And then you take a credit. What does that mean? Is that FV or PV? Eventually, it's going to be hard to distinguish.
It's present value.
Right, so we know the present value is whatever this is, right?
Mhm.
Sorry, not future value. Present value is $1,300. What else?
I is 0.018 divided by 12.
Yeah, what does that? Try that.
Um, 0.0015.
0. What, sorry? 0.0?
15.
What about N? N is easy, 24, right? R is missing. Let's set this up. So we have 1,300 equals R times this whole thing. 1 minus 1 plus 0.015 to the power of negative N, negative 24, all over I, 0.015, close bracket. Okay, why don't we try this at the same time? You tell me what we plug into the calculator first.
0.0515 to the power of negative 24.
Yeah, try that. Plug that in the calculator.
I got 5.9403.
Okay, now you do 1 minus answer. There's a button on your calculator that says answer. I don't know if you've ever used it.
No.
What's your calculator? I think I have this. I have one that looks like TI-30X IIS, right?
TI-30XA.
Okay. You see on the minus button on the very bottom, like minus button that's with a bracket. What does it say above it? Does it say ANS?
No.
Okay, whatever. You just memorize that number. You just whatever you got for this bit, right? For this bit, you just kind of memorize it or you write it down, and then you're gonna do 1 minus that.
Okay. See, I already forgot the number, so I'm gonna do it again.
There's a button. I don't know. Does it not say ANS anywhere or answer or something? Because that way you don't have to remember the numbers.
Okay, I got a negative number.
Oh, no, negative number is not good because if we get a negative number here, we're going to get R as a negative number, which is not right, okay? So 1 plus 0.15 to the power of negative 24, 0.15 to the power of negative 24. that is 0.6669. And then when you do 1 minus that, you get 0.300. So I have 0.0300 all over 0.015 equals 1300. I'm just going to plug that in, divided by 0.015. So I get 1300 is equals to 20.03 R. What do we do next?
You divide.
Right. So once you, this part I think you're good with, right?
Mm-hmm.
Try plugging that.
$64.902.
Okay, so what does that mean in the context of this question? If you were to write a like a therefore statement,
That's gonna be your monthly payment.
yeah, so you're gonna pay that amount for how long? Every month for how many years?
2 years.
Right, and that's it, right? Which is a lot actually. Maybe not a lot. I
Mhm.
don't know, $60 a month. So let's see how much you end up paying in interest. So it was like 60 something, right? So you pay 60 every month, so 12 times a year, you pay it for 2 years. Let's see how much you end up paying just in interest. 60 times 12 times 2. It's not that bad. You pay $140 in interest. So this isn't that bad. Okay.
Mhm.
But the longer you are paying interest for, the more you end up paying. That's why houses, like, because you pay for like 25 years, it's like outrageous the amount of interest you end up paying them.
Uh-huh.
Even cars and phones, they'll be in their thousands and thousands. Here, let's look at this one. What is given?
The present value is is it 50?
Is it 50? Does that sound like a present value? So it has some present value, okay? What this person did was he put in $50 initially as down payment, and the rest of the money he's borrowed, okay? We don't know how much he's borrowed, so PV is missing.
Okay.
What else?
Wait, someone's knocking on my door.
Okay,
I'll be
okay,
right back.
cool.
Anyways, I'm back.
All right.
Is R 50?
No, so R, actually it says here payments are $40 each, so R is 40.
So what's 50?
50 is the down payment, which once we find the present value, we're going to add 50 to that. Then that's going to be the selling price of the player.
Okay.
Okay. What else do we know here? We know it's 18% compounded monthly, right? So we can just try doing 0.18 divided by 12.
Um, 0.015.
Right, so that's I is 0.015, and then finally N is how much? 10 monthly payments, right? So N is gonna be 10. Okay. It doesn't say 10 years, it says 10 months, and we know this is being compounded monthly, so N is 10. N is the number of compounding periods. If you want, you can also convert 10 months into years by first dividing by a 12, yeah? This will be the amount in years, and then you multiply this by a 12 because it's compounded monthly. They cancel out. N is 10 here, okay?
Okay.
So we just do R 1 minus 1.015 to the power of negative 10 over 0.015. R was also given, sorry, that was 40, and that's going to give us the present value. So 40 times let me just do this step by step. 1 minus 1.015 to the power of -10 divided by 0.015 times 40. So this gives me PV is 368.89, okay? But then you're gonna add the 50 that he down payment initially to actually find the total money that the player is worth, which it would be 89. Cool.
Okay.
How much interest would he have paid? Well, we know he paid 40 every month for 10 months, so he actually paid 400, and we know the price was 418, so he paid 18.89 in interest. Cool.
Mhm.
That's it. That's pretty much it about how these questions go. The algebra is going to be a little difficult, right? Like if I is missing, then that's going to be a completely different problem altogether. But if n is missing, we use logs. If r is missing, we're just going to divide both sides by the big bracket. Okay.
Mhm.
All right, cool. Let's call it a day there for today.